We're starting now chapter 2 in probability and statistics, and we are finally talking about probability. And what is this? What is this all about? We are going to learn how to estimate how the probability of an outcome of an event to happen on a certain trial or experiment. Now, you may have situations in which you are given a wide range of data, and from that data, you'll have access to a way to calculate the probability of something to happen related to that data. Or you can just calculate and make an estimate of the probability of something in a theoretical situation to occur. This is called a theoretical estimation. You know for a long time that probability ranges from 0 to 1, okay, in which 0 means that there is no chance for something to happen, for that outcome to happen, and 1, you have absolute certainty that the outcome is going to happen. And you also know for a long time that the way to calculate the probability of an event A to happen, which is represented, by the way, by P of A, is given by the number of ways that the event can happen, that is given by N of A, divided by the total number of ways that all events can happen, and that is given by N of E, in which E is the universal set. You have practiced with this in a previous year, so I'm taking that you know what this means. I'm taking that you know that you also know what this means. What is the probability of an event A not to happen? That is just 1 minus the probability of it happening, okay? And is given also by this formula over here. If you know the total number of ways that all events can happen and the number of ways that A can happen, so if you apply this, this is virtually the same as that. If you divide this into fractions, you have N of E divided by N of E, that's 1, minus N of A divided by N of E, which is the probability of A, as mentioned before. What if you have two situations and you want to calculate the probability of one event A or another event B to happen? Okay, one or another. This is represented by this Venn diagram, in which this is all possible events. The rectangle represents the range of all possible events. Then each one of the circles represent the events A and B. And if you want to calculate the probability of A or B to happen, that is represented by this notation over here, A union with B, then obviously this is going to be given by the number of ways that either A or B can happen divided by N of E, the number of all possible ways that all events can happen. And then you can divide this into two fractions. Each one of them basically corresponds to the probability of A and the probability of B. So if you want to calculate the probability of either A or B to happen, that's basically just the sum of the probability of A to happen and the probability of B to happen. This happens when you apply just that, when the events are mutually exclusive, right? What does this mean? That means that you don't have events of A and B happening at the same time. When this happens, we are talking about not mutually exclusive, all right? You have events of A that also belong to the set of events of B. And in that case, you cannot apply just that. Why is that? If you would do that, what would be happening? You would be calculating the probability of A, the probability of B, but that part shadowed over here, you would be counting 2 times, right? And actually, the probability is given just by that over there. You cannot count this part that belongs to both twice, so you have to remove it. That's why you have that part over there. Okay, so again, what do? I think that is more visual if you start with the last bit. To calculate the probability of A or B to happen when they are not mutually exclusive, you calculate the probability of A, you calculate the probability of B, add them together, but you also have to calculate the probability of A and B to happen, okay? A and B at the same time to happen, and then you have to take it out, okay? And once you do that, you have the probability of A and B altogether. This is given by the formula over here. So the number of ways that A or B can happen minus the number of ways that A and B can happen divided by the total number of ways that all events can happen. Then you can divide this into 3 different fractions. Each one of these correspond to this probability that I mentioned a little while ago. This makes much more sense solving exercises. So I invite you to either use this page or not, because this is basically common sense, to solve questions in a textbook or exam questions. You don't have many. This is too simple. But practice enough so you get comfortable with this, so we can move on to more interesting and complex things.